All right, so here is section 4.5 for Algebra 1. It's called Literal Equations and Formulas. And I don't think I've ever used this term, literal equation, but that's fine. We'll use it, and I think it's a good term to use. So here's my little cartoon I found. I will literally die if you don't stop using hyperboles incorrectly. Or I think my favorite one that I might like to say when I'm being over dramatic is, this was literally the worst day of my life, which obviously it wasn't unless something horrible happens. Okay, let's actually learn what a literal equation is. What is a literal equation? So if a letter is used to stand for one or more of the constants, as in 3x plus a equals 44, the equation is said to be a literal equation. So you see we have two variables, x and a. The word literal comes from the Latin word litera, I hope I pronounced it right, which means letter. So let's take this literal equation, 3x plus a equals 44, and solve for x. Okay, so we want to get x by itself. What we're used to seeing is we're used to a being a number, right? But instead we have a letter. So we're still going to have to get a over from the left side to the right side in order to get x by itself. So these questions are kind of tricky to begin with, because you have to make sure you're solving for the right variable or letter, since there is more than one in the equation. So we want to get rid of everything that's in the way of the x being by itself. So I'm going to subtract a from both sides. So a minus a, that's going to be 0. And we'll have 3x by itself on the left-hand side. Okay, that looks too suspiciously like a 9. Let's do 44 minus an adorable a. Okay, now we don't know what a is. So that means that we can't take 44 minus a and get a number. So we have to leave that as 44 minus a. And just like we would do in a typical equation, to get the x by itself, we would divide both sides by 3. So I ran out of room. I'm going to try to make room by doing this. And I'm going to fix this typo simultaneously because it's bothering me. Okay. Hopefully I have enough room. Oh, I can make a little more. There we go. Now that should be plenty of room. Okay. So I'm going to divide both sides by 3 to get x by itself. Now I could write my answer as 44 minus a divided by 3. That is the correct answer. I do want to show you how to write it another way. So if we wanted to simplify this a little, which we will want to work towards simplifying our answers as much as we can, we would split up the 44 and then the minus a. And basically sometimes things will cancel from the fractions, and that's why we want to split them up. In this case, it doesn't simplify, so really either answer would be perfectly acceptable. And we can't reduce this improper fraction. You could change it to a mixed number, but if you recall, an improper fraction is just fine. So this result is called a formula for x in terms of a. So this part, in terms of a, is important. If we had solved for a, we would call it a formula for a in terms of x. Okay, so let's do an example. Solve 5y plus 3 equals 17 for y in terms of c. So that means if you want to solve for y, your final answer should say y equals something. So you have to pay attention to what you're solving for. Okay, so we want to solve for y. So we're going to subtract 3c from both sides because we're working to get y by itself. So 5y equals 17 minus 3c. And if you would like to write the right-hand side as negative 3 plus 17, that's fine too. It's not required. So we'll divide both sides by 5, cancel the 5s, and we get y equals, and again, I will work to separate the fractions. 17 minus 3c divided by 5. So I'll rewrite this as 17 fifths minus 3 fifths times c. And that's how we usually write a fraction like that. We don't leave the c on the numerator. We write the numerical fraction by itself, 3 fifths, and then we put the c out to the side versus writing it like this. So it's not incorrect. I'm just letting you know kind of what's proper grammar for math. So we couldn't reduce 17 fifths or 3 fifths, so we leave it just like that. Okay, here's another example. Now we have solve A equals LW for L in terms of W. So what we're dealing with these literal equations is these are often formulas. So this is a mathematics formula, but there are formulas for physics and chemistry that are literal equations that you probably already learned how to solve some literal equations in physical science and you just didn't realize it. So this one is actually A is for area and L is for length and W is for width. Area equals length times width. And that's for the area of a rectangle or a square. Well, I guess a square has the same sides, so you might write that a little differently. Okay, so we're going to try to solve for L. So that means our answer at the bottom needs to be L equals something. L has to be by itself. Okay, so L right now, how is it attached to the W? It is attached, they're right next to each other, which means they're attached by multiplication. So in order to get rid of W, we have to divide both sides by W, because W divided by W is 1. So now on the right-hand side, we have an L, and on the left side, we have A divided by W. Now it is nice to write the L on the left-hand side because we're asked to solve for L. So I like to have the L first. L equals A divided by W. Okay, now we're going to see how this works in a word problem. So the length L of a rectangle is given in terms of the area A and width W by the formula L equals A divided by W. So that's what I was talking about, area and width and length of a rectangle. So we're supposed to find the length if A is 300 inches squared, or square inches, and W is 8 inches. So we'll call this part A. So we know that L equals A divided by W, and so we were given that the area is 300, and the width is 8, W is 8, okay? Now usually with this kind of geometry we would figure out what 300 divided by 8 is. And if you plug that in a calculator, it comes out to 37.5. And then we always want to write our answer with our correct unit, so 37.5 inches. On a test or something, if you were to reduce this, let's see, 300 divided by 4 is 75. So if you rewrote this, you divided both the bottom and the top by 4, and you wrote your answer like that within inches, it would be correct, unless the directions say to find it written as a decimal. Okay, so part B. A is 0.4 square miles, and W is 0.025 square miles. So again, I'm going to write the formula, and then I'm going to plug in A and W. So A is 0.4 square miles. Oops, W shouldn't be square miles. That's funny. That's a typo in the book and on my slides. Okay, so L is equal to 0.4 square miles and W is equal to 0.025. Okay, and I don't want to divide a decimal, so I'm going to use my calculator and get that the length is 16, and I want to write my final answer with a unit, 16 miles. So we did both A and B, and that's it. Okay, let's do one more example. The definition of rate of speed is distance divided by time. I don't want to let S stand for rate. I want to let R stand for rate. D stand for distance and T stand for time. Write a formula for R in terms of D and T. Okay, that's what we're supposed to do first. The definition of rate of speed is distance divided by time. So R equals D divided by T. All right. Part B says solve for D in terms of R and T. So what that means is our answer should be D equals something. So we want to have D by itself. Okay, and I have T on the denominator. I need to get rid of the T. I'm taking D and dividing by T. So I want to do the opposite operation of division. And I want to multiply both sides by T. So remember when we used to solve equations? And we will still continue to solve equations like this. W divided by 5 equals 15. You would multiply both sides by 5 to get the 5 to go away, to get W equals 75. So that's what we're doing here. Our T's are going to cancel, and we get T times R. We can write that as TR equals D. And that's a correct answer. It's nice to have the D on the left-hand side because that's what we were asked to solve for. And then TR is a perfectly correct answer. However, we always see this equation written D equals RT. We put the R first. So I just wanted you to see that as well. Distance equals rate times time. But if you wrote D equals TR, that would be a perfectly good answer. Okay, so let's do part C over here. Evaluate D, that means find D, when the speed is 55 miles. Wow, I think the autocorrect got me here per hour. I must have made a typo. And the time is 4.2 hours. So D equals rate times time. D equals, okay, the rate is 55 miles per hour. And the time is 4.2 hours. So you have to make sure the units line up correctly. And we can use a calculator to do that kind of math. D equals 231. And it says to evaluate D, so it means I don't have to write my answer as 231 miles. Isn't that funny? So it didn't say to find the distance when the speed is 55 miles per hour. It said evaluate D. So I can actually just leave my answer like that, 231. And that's it.